Hi and welcome back to this segment where I would now like to look at how to solve non-homogeneous system. In the previous one we looked at homogeneous systems and we saw how if we have we can either have the trivial solution or the non-trivial solution. Okay, non-homogeneous systems. And yeah, for the non-trivial solutions we saw where we can have where we have less equations compared to the unknowns, and in such a case we have basic variables and the free variables, and we write the basic variables in terms of the free variables, and we have the general solution, and for a particular choice of free variables you can always have the particular solution. Now in this case we are going to solve an example. We are going to see an example how to solve a homogeneous system, non-homogeneous system, that is ax equals to b, and in this case b is not zero. Not zero meaning all of them are not zero. Okay, alright, or we can say what did I say? Okay, no, not zero meaning at least one entry or one element in B is non-zero. Then that means that B is not the zero vector. Okay, now let's see, maybe we start with an example here to explain what we want to say. As usual, I am not going to write down the whole system for sake of time and space, so I will write down the augmented system. Remember, for the non-homogeneous I said it didn't make sense to write the augmented system because the b vector was 0, okay, and therefore there wasn't anything going to change. However, since this is b is non-zero, then we have to write the augmented system. So the augmented system goes as follows: 1 2 2 3, and then the right hand side we have 4 here. What else? We have 2 4 1 3 5, and then we have 3 6 1 4 and 7. Okay, so we do our Gaussian elimination, and then we start. 1 is our pivot, so we leave it there. Okay, nothing changes. So we have 1 2 2 3 and 4. Set this to 0 by, okay, how do we set that to 0? We multiply row 1 with -2 and add row 2 and put the result in row 2. So multiply by -2 and add, we have 0. Multiply by -2 and add, we have a 0. Multiply by -2, that is -4, and add 1, we have -3. Okay, that's terrible writing, -3. And then multiply by -2, that is -6, and we add 3, we get -3. Then multiply by 2, that is -8, and add 5, we get -3. Okay, what about in row 3? What are we going to have? Okay, we multiply row 1 by 3 and add row 3 and put the result in row 3. So multiply by -3 and add, we have 0. Multiply by -3 and add, we have 0. Multiply by -3, that is -6, and add 1, we have -5. And then multiply by -3, that is -9, and add 4, we have -5. Multiply by -3, that is -12, and add 7, we get -5. Okay, alright, so we continue, and then row 1 goes to row 1. Okay, 1 2 2 3 4, and then this is our new pivot. Okay, so as such there's nothing we are going to change here. We simply write it as it was, and then whatever we are going to do here, since you know we have -3, and this is -5, whatever we do to this -3 to set this to 0, it's going to affect everything here. So whatever we are going to do, everything here is going to be 0. Maybe just for completeness sake, someone may have to say that, hey, what did we use here? Perhaps we could just multiply this by multiply by what do we do to get 5? Multiply by -5/3. Okay, so if we multiply it by -5 divide by 3, we get +5. Add this, we get 0. The same here we get, and the same here, so we have 0. So we multiplied. So to row 3 we added the a product, this combination, -5/3 times the entry in row 2 plus row 3, and then we put the result in row 3. So you can see here. Now I won't again write down the full equation here, but by back substitution we see that we have 2 equations, because this 0 here, that means we have no equation, everything is 0, 0. So we have 2 equations. How many unknowns? 1, 2, 3, 4, and 4 unknowns. Therefore, for this non-homogeneous system, we are going to do exactly what we did for the homogeneous system, by choosing what is going to be the basic depending on the pivotal positions. This is a pivot, and this is a pivot. Therefore, this pivot here, which corresponds to x1, and this pivot here, which corresponds to x1, x2, x3, x1 and x3 are going to be our basic variables. There are no prizes for guessing that x2 and x4 are going to be what are they? The free. Please note that this is purely coincidental, that also in the previous example we had, it was, I think, the same, which were basic, and the ones which were free. So please don't take it that it will always be x1 and x3 basic, x4 and x4 which are free. No, we said basic depending on the pivots, and then the rest are free. So from the second row here, or this second row here, we see that we can pick the equation -3 x3 minus 3 x4 equals to -3. Okay, so we can say that now -3 x3. See, okay, we can divide through, and divide through by 3, that is 1, it goes out. So we have that -x3 equals to -1 plus x4. -1 plus x4, or we could write and say that x3 equals to 1 minus x4. Okay, if we haven't made a mistake. And now from this equation here, we are going to write that x1 x2 x1 plus 2x2 plus 2x3, okay, x1 2x2 2x3 plus 3x4 equals to 4. And when we have that, so we can write, remember we said x1 is basic, and then we can first say that minus 2x3 minus 3x4 plus 4. Okay, so x1 we said is basic, x2 is free, and x4 is free. So we substitute for x3 because x3 is basic. So we are going to substitute for x3, which is which expression we already have here in terms of x4, in terms of the base, or in terms of the free variable x4. So that is what we do. You just substitute where you have x3, you do that, then minus 3x4 plus 4. So please allow me, if we do the algebra, what solution, what do we get here? I'm quite lazy, I don't want to go through all this. So okay, yes, I have no choice. This is that, this is minus 2, this is plus 2x4 minus 3x4 plus 4. So this and that, we have positive 2, then x2, okay, minus 2x2, and then 2x4, 2 minus 3, we have minus x4. Hopefully, if I haven't made an error, so we can write down our solution as x1, x2, x3, and x4. Please allow us, for the sake of time, to split it right here. Okay, we have the constant, okay, 2 for x1, and then here we have a 0, here we have a 0, and then here we have a 0. This first part, okay. Then in terms of x2, what does x1 have here? It has a negative 2, and then x2 is x2, so we have 1. What about x3? Is x3 written in terms of x2? No, so we put a 0. And then x4, is x4 written in terms of x2? Yes. Is it so? x4, oh no, sorry, x4 is free, so here we also have a 0. Then we have plus x4, so we can as well start here. x4 is x4, so here we have 1. And then this is x3. Is x3 written in terms of x4? Yes, x3 is 1 minus x4. That means I forgot the constant here for x3. x3 has a constant. This is x1, x2, x3, and what is the constant here? It is 1. Okay, but then also x3 is written in terms of x4, and the coefficient for x4 in terms of x3 is negative 1 here, so we shall put here a negative 1. And then is this is x4, x3, and then is x2. x2 is free, so here this is a 0. And then do we have x1 written in terms of x4? Yes, and the coefficient is negative 1, so we can write negative 1. And therefore what we have here constitutes our general solution. Okay, remember we said that for any particular choice of the variables x2 and x4, we generate a particular solution. Okay, all right, thank you.